for the basically our formula is y equals to ax squared plus bx plus c. And for the discriminant, it's talking about that how many points or the solution when y equals to 0, that means on x-axis. Okay, so that for the x-axis, that means y equal to 0. We are going to say this one. And for our formula, that is x equals to negative b plus minus radical b squared minus 4ac divided by 2a. And here, we will say that this one is our discriminant delta. For this delta means what? If this b squared minus 4ac is greater than 0, if this term greater than 0, that means our negative b plus and minus a number. That means we have two solutions for x. And on the other hand, if this term only equals to 0, b squared minus 4ac equals to 0, negative b plus minus 0, that means only negative b divided by 2a, so that our x only negative b divided by 2a, only one solution. And the last, greater than 0 equal to 0, the last one is more than the 0. In here, radical inside with a negative number, we cannot solve it. There is no solution here. So that, no solution. The number of roots will be this one. Greater than 0, that's 2 roots. Equal to 0, 1 root, or we will say equals roots. And smaller than 0 will be no roots. And now from the graph, here we are going to say how to say delta greater than 0 have two solutions. We say we have 2 points here. A curve pass through it. This one we can say the delta is greater than 0. And one more thing. Here, the a, the first term, is greater than 0. Because in the infinitive, always positive must be from the a. On the other hand, if the curve also passing these two, but like this one is a smaller than 0. And next, we are talking about when delta equals to 0, but the a is positive or negative. Because on the graph, we say only have one solution. That means one point on the x-axis here. A line pass through here. Just touch the x-axis. That is a greater than 0. And other one, from the downwards part, that is a smaller than 0. This figure is say delta equal to 0. The last one is talking about the delta smaller than 0. For this one, delta smaller than 0, we have some question, is difficulty. First, draw the graph. That is x-axis, that is the y-axis. And because we don't have any points there, so that if for a greater than 0, have a line here, don't touch. And if we say about a smaller than 0, we will like this. We cannot interchange about a smaller than 0 in upper part. Why? Because for the left and right side, the line will be always go downwards. If this part going up, That means we have 2 points cutting on the x-axis. The delta will not be smaller than 0. Now, let me erase one thing and talk about. It's about the graph. We have some question like this. Y equals to ax squared plus bx plus c. The same thing. If I say that the y is always positive. What does this mean? For the y is always positive, that means for the x-axis upper part always positive. Upper part. So we are saying the a must be greater than 0. And the delta should be smaller than 0. Why we say always positive, but the delta is smaller than 0? Because always positive means we don't touch the x-axis. For don't touch the x-axis, the delta must be negative. Don't think about it. We say positive, then delta is positive. On the other hand, we can change the question is y is always negative. If the y's are always negative, that means the downward part, the discretized one, we will say a is smaller than 0 and the delta is smaller than 0 also. Actually, we say that the always positive or always negative should be delta equal to 0. Only one thing is a is positive or negative.